In this video, let us continue to solve more problems based on the sine rule. Alright, so here is a problem which reads like this. It says, in any triangle ABC, prove that sine of b minus c divided by sine of b plus c equals b square minus c square divided by a square. Alright, so what we're going to do here is, first of all, write the sine rule. So let a by sine a equals b by sine b equals c by sine c be equal to k. So once we equate everything to k, what happens? We're going to get this. Equate individually everything to k. A by sine a equals k, then what happens? A will be equal to k sine a, and then b will be equal to k sine b, and c will be equal to k sine c. Alright? Why these? Well, the reason is, look at the right hand side, we've got b square minus c square by a square. In this problem, what we're going to do is, we're going to find, the values for b, c, and a, just like this we found here, then have them substituted in these, and then get back to this. So we're going to start off with the right hand side and then end up in the left hand side. Alright? So now that we found this, let's take the RHS, the right hand side, which is equal to b square minus c square divided by a square. Now substituting the values of a, b, and c respectively in this right hand side equation. So b is k sine b, so it will be k square sine square b minus k square sine square c divided by k square sine square a. Alright. So now you know that k square is same in all the terms. So take out the k square from the numerator. So that becomes k square of sine square b minus sine square c divided by k square times sine square a. The k square gets cancelled, and what we are left with is sine square b minus sine square c divided by sine square a. So the next step, what we are going to do is, now here it is of the form a square minus b square. So that's going to give us sine of b plus c, a plus b into a minus b. So sine of b plus c into sine of b minus c divided by sine square a. Alright. Now, before that, we know that it is clearly mentioned in any triangle. In a triangle, you know that the angles a plus b plus c, if at all they're named that way, are equal to 180 degrees, right? So, from this we can say b plus c equals pi minus a, and so on. So here we've got sine of b plus c, right? So let's replace the b plus c by pi minus a. The reason being, when a number comes in, we can kind of narrow the problem down to something. That's the reason. And then sine of pi minus a times sine of b minus c divided by sine square a. So now if you see, this is almost, it is sine of 180 minus theta. Sine of 180 minus theta lies in the second quadrant, right? It lies in the second quadrant. Second quadrant, you know that sine is positive, and then 180 doesn't change anything. So therefore, it's going to be sine. So it's going to be sine a. So sine a times sine of b minus c divided by sine square a. So the sine a and one sine a gets cancelled, and what we're getting is sine of b minus c divided by sine of a. And now if you can see the left hand side, we've almost got there, only the sine a part is missing. But now I'd like you to remember the results based on the sine rule that we did in the video before the last, So in that, if you would have noticed, sine a is equal to sine of b plus c, right? So we're going to write sine of b minus c divided by, in the place of sine a, we're going to write sine of b plus c. So therefore, we proved. So started off with from right hand side and ended up with LHS proving this equation. For those of you who didn't get this sine a becoming sine b plus c part, well, sine b plus c equals sine a. Or for that matter, anything, sine of a plus b will be equal to sine of the angle that is missing here. Considering we are talking about a triangle and then there are three angles, then we've named it a, b, and c. So in this case, it'll be sine of c, right? I'm sure you would have guessed it already. So that's what's the explanation for this one. Otherwise, it's a pretty simple problem. Well, of course, since this is the first time, it should have been a little different. But, once you get the hang of things, you're going to know, all right, this is how I go about solving this problem. So you really need to practice for that. So this ends this problem. I'll see you in the forthcoming videos with more problems based on the sine rule.